Hi, so in this video, we're going to be talking about annuities, and we're going to relate them to the geometric series. So here's this example here. A deposit is made at the beginning of each year. A deposit of $1,000 is made at the beginning of each year and earns 4% interest, compounded annually. What's the value of this annuity at the end of the 30th year? So this is a really good application for geometric series because in an annuity, it's a sequence of periodic payments. And the payments could be loan payments or investments. So let's talk about that. So in the 30th year, if you think about it, it said 30 years. You're making a deposit at the beginning of the year, and that deposit is $1,000. Okay, so you're making a $1,000 deposit at the beginning of the year, each year, and each year it's going to earn 4% interest compounded annually. And it says, what's the value at the end of the 30th year? So think about that last year. So for that last year, you deposit, in the beginning of the year, you're going to deposit the $1,000. So that amount is going to be $1,000, and it's only going to be able to accumulate interest for that 1 year, that 30th year. The one before that, however, you deposit it at the beginning of the 29th year, and it's going to be able to accumulate interest for 2 years. So it'll have 1.04 times 1.04, which is 1.04 squared. So it's going to have that much money accumulating with it. It's going to earn that 4% for 2 years. And so on. You continue this pattern. The next one, the 28th year would be 3, 1.04 to the third power. And then that first deposit has been sitting in there for 30 years, okay? So it's that first deposit of $1,000 ends up being 1.04. It earns that 4% interest, but it sits in there for 30 years. So that's raised to the 30th power. And so if you were to try to figure out what's the value of the annuity at the end of the 30th year, you could actually add all of these values up and get the amount, the total amount that it's going to be at the end of the 30 years. And so on a previous video, we did the sum of a finite geometric series, and that's what we're going to do here. And so just recall back what our sum formula was for the finite geometric series. So the sum was a sub 1, and then you had 1 minus r to the nth power. And that was all over 1 minus r. Okay, so if we want to find our total over 30 years for our annuity, we can actually plug in the first term. So we're going to do the sum over 30 years. And the first term is this 1,000 times 1.04. Okay, so that's a sub 1. Then we multiply that by 1 minus, and our r value is 1.04, our rate. You're getting 4% each year, so you're getting the full $1,000 that you put in plus 4% of that. So that's our rate. And again, that's being raised to the 30th power because we're talking about over a period of 30 years. And then on the very bottom here, we have 1 minus our rate again, 1 minus 1.04. And so it's a really neat application for this. And so I had put this in my calculator. So when I put it in my calculator, I don't know if you can kind of see that, but 1,000, okay? And I'll just show you, I guess, on the back end here. 1,000 times 1.04 times, and then I did parentheses, 1 minus 1.04 to the 30th power, and I closed it out. And on that one I got negative 2,333.13. So that was that. And then I took that answer and I divided it by, and I put parentheses around what I'm dividing it by, 1 minus 1.04. And I got that number. So 58,000. So it's approximately $58,328.34. So that's the value of the annuity. And so, when you're older and you're talking about annuities and retirement, things like that, this is a really good application for that. In your homework, if you're doing anything like that, you might have, let's say, a retirement fund or something like that. It could be compounded annually. There's a few different examples that you could have, but I hope this helps you to know that, the geometric series is actually relating to something in real life, annuities. And I'll see you in the next video.